Okay, here are solutions to quiz 7 from Math 251. First problem, we're asked to find this derivative. Really, I'm most interested in you doing it using logarithmic differentiation. For part A, I have you do it using the chain rule, just so that so you know what answer you should end up with in part B. So anyways, the derivative, maybe I'll say f prime of x equals, using the chain rule, the outside function is e to the x. So the derivative of e to the x is e to the x. So I'll leave that alone, times the derivative of sine of x. And the derivative of sine of x is cosine of x. So using the chain rule, you get something like this. Review at this point, I think. Logarithmic differentiation, however, to do that, we'll set this up as an equation, y equals sine of x, and what we'll try to do is find y prime. To make it logarithmic differentiation, we'll take the log of both sides. I think probably makes sense to take the natural log of both sides, although you could take other logs. It'll just make things a little bit harder. If you take the natural log of both sides, you're left with just sine of x on the right. And now we differentiate. Take the derivative of both sides. Derivative of natural log of y is 1 over y prime. This is chain rule here. Outside function is natural log of x. Inside function is y prime. And derivative of sine is cosine. And so solving for y prime, we get y prime is y times cosine of x. But you don't want to define the derivative of y in terms of y. So what we'll do is we'll write y is e to the sine of x and multiply that by cosine of x. Just substitute back in y is equal to e sine of x, which is the same thing we got up here, so that's good. Number 2. Okay, so the key point here is that x and y are both functions. I specify they're functions of t, but it really doesn't matter what variable you have, just the fact that these are both functions. And we're asked to find the derivative of x. We want to find x prime here. And it tells us that x is 2, y is 1, and y prime is 60. So, okay, the way we'll do that is we'll start with this equation that's given, 2 to the x equals y squared natural log of 2, plus some constant, 3.306853. The reason I put that in is because I want 2 and 1 to be a point on this curve. So when x equals 2 and y equals 1, you need this constant to make the equation equal. It's an approximation, but good enough. Anyways, take the take the derivative of both sides. Derivative of 2 to the x. You might think it's 2 to the x natural log of 2, but we're not done here because x itself is a function. So this is a chain rule over here. Outside function, I guess it's 2 to the x. The inside function is x. X itself is a function. So we have to multiply that by x prime. And over here, I think this one looks a little trickier than it is. The derivative of this is 0. This just goes away. It's a constant. But natural log of 2 is a constant. Don't treat this like a product rule, because natural log of 2 is not a function. It's just a constant. So we can leave that alone and then multiply that by the derivative of y squared. Derivative of y squared is 2y times y prime. See, we got another chain rule here. Outside function is x squared, inside function is y. So you get here. And then what do we want to do? We want to find x prime. So to find x prime, divide both sides by all this mess. X prime equals natural log of 2 times 2y y prime divided by natural log of 2 times 2 to the x. Or those natural logs of 2 cancel out, so we get 2y y prime over 2 to the x. But we're not done. We want to find this derivative when x equals 2, y equals 1, and this derivative is 60. So now we plug in. Where do I go? Maybe back over here. If we plug in x equals 2, you get 2 squared on the bottom, y equals 1, 2 times 1, and y prime is 60. So we get this, which is what, 120 over 4, which is 30. So final answer here is just 30. And I guess that is the end of this problem and thus this quiz.